Dead set legend. That's how I'm going to start this video, dead set legend. Okay, so Hamish has got it. What was the function? Yeah, it was. Well done. X minus 2 all squared. So 1 minus 2 is negative 1, goes into the function, which is unknown. Well, it's known now, but and squared, and then out comes 1, because minus 1 squared. 2 minus 2 is 0. 0 squared is 0. 3 minus 2 is 1. 1 squared is 0. Oh, sorry, 1 squared is 1. 4 minus 2 is 2. 2 squared is 4. So it fits the rule, and it's the rule I was thinking of. So, I mean, ultimately with a function, you know, we need to know the rule of the function in order to be able to calculate it ourselves. But in a weird way, that sort of, I called it last lesson a black box, that kind of idea that you don't know what's happening inside the function. But as long as you can input stuff and output stuff, you can sort of use the function, right? I could chuck in 7, and as long as I know that out of it comes 25, then, you know, at least I know what's going on. Knowing the insides of the function helps us. So we've got this idea of inputs, by the way, and that's the domain, if you remember. And then we've got this idea of outputs, which is the range. Okay, so this first slide, by the way, is just conceptual stuff, and then I've got some formal notes for you to take after we've unpacked it a little bit. So, as we just discussed, we've now can replace the question mark with what Hamish said, which is f of x equals x minus 2 squared. So x is the input. It's just the input, right? It says it on the box. It's not f, it's f of x. F of x. F with an input of x. We know that input can be anything. And when I say anything, I mean we can talk about f of 3 and get an output. We know the output is 1. We can see that in the black box in the left-hand corner there, but also because we can apply the rule for ourselves. 3 minus 2 is 1, 1 squared is 1. So we can say we get an output like that. We can also go f of c, can't we? We don't know what c is, but that would just be c minus 2 all squared, right? For some value of c. It's a different variable, but we effectively replace the input that we're given, which is x in general, and we replace it with an expression. The expression might be a number like 3, which gives us a specific value output, which is 1. It could be another variable like c, in which case the output is c minus 2. We've replaced the x with the c. We don't replace the x minus 2 with a c. We just replace what the input was, which was x, with the new input, which is c. Are we okay so far with that? We're going to come back to this in a couple of slides' time, but I won't unpack it any further now. But keep that in mind, that what we put inside the brackets there after the f of is just what the new input is for the rule that we have been given or that we create for ourselves. Okay, it's x minus 2 all squared can be seen as the rule which provides us with the output, y. X is the input, y is the output, x minus 2 all squared is the rule that gives us that output. X minus 2 all squared is synonymous with y. X minus 2 all squared is the output. Okay? I'm making this really clear because this rest of this lesson relies on you going, I'm 100% on board with this. It's not hard, but it needs to be crystal clear in your head. Each step needs to be crystal clear. Good. Okay. So what happens inside that black box doesn't matter to us. Looking down the bottom left-hand corner now. So I'm just going to pick one value. That's, let's say 3 output in 3 gets input. And out comes 1. What happens inside that box doesn't really matter, but to us, if we're just using the box. But if we wanted to, we could sort of break that rule down into its composite parts, right? Into its little parts. So we could say that when 3 is input, I want you to take away 2 from it, and then I want you to square it. And we'll put an arrow here. So in fact, this function could be broken down into 2 mini functions, if you like. Function 1, subtract 2. Function 2, square that. And that would kind of work, wouldn't it? So in terms of looking at the inside, this is how the sausage is made, is a saying. The 3 comes into the box and it gets put into the first part of the function where 2 is taken away from it. That would give me an output of 1, and then 1 is squared to give me 1, and then the output is 1. Does that kind of make sense too? So actually, there are 2 functions going on. There's subtract 2, and then there is square. So ultimately, we can say that a function of some complexity is actually a composite. Composite means made up of, composed of. You okay with that word as an English word? To be composed of something means to be made up of. So a function is often a composite of little mini functions. We okay with that? Cool. Because we are looking at composite functions today. Composite functions, we're going to be looking at notation and how to create a composite function from 2 other given functions. These are your theory notes. Give you a moment to get organised theory-wise. So, composite function made up of 2 or more other functions. I think for this course, I'm pretty confident that they really tend to just focus on just 2 functions. So a new function is created when you have a composite function. A new function is created. For example, in the slide previous, I won't flick back to it, we have a function which was x minus 2 all squared, which was made up of 2 other functions. Subtract 2, x minus 2, and then square. We're going to see how that breaks down though. The notation there, this is kind of called fog notation. You need to see it. I'd like you to use it when you can. It says in the course document you need to be informally introduced to it. So you've got an F, and then you've got a little circle, and then you've got G, and then you've got bracket X bracket. Now, I should note then that this, I'll just change colours a bit. This is the new function. So it's F composed with G is how you say it. F composed with G, write that down if you feel like you need to, but you can just remember if you like. F composed with G, deliberate pause, of X. F composed of G, of X. So it's not F composed with G of X. So the of X does not sit with G. It's F composed with G of X. Does that kind of make sense? And this is the conceptual stuff that you need to get right in your head. You need to see F composed with G as the new function. In fact, some people, I won't do this because I don't think the course does, and so I'm going to put it in blue and you don't have to write it down, is they might use something like H of X equals F composed with G of X. In other words, there's a new function H that is composed of F and G, basically. That's not me swearing, that's saying F and G. Okay, good with that? Any questions before we move on? Awesome sauce. Okay, I think I can zoom out now. Yep, it'll all make sense as we go along. So, this is what it means. Slide 2 there. Apply the rule of G of X to the input of F of X. Apply the rule of G of X to the input of F of X. I'll give you a moment to write that down, then I'll chat to it. The thing that might cause a little bit of trickiness is that left to right, F composed with G feels like you do F first and then you do G. That's not how it works. Okay, you've got to do G first, and then with the result of G, we put it into F. And I've got some examples that will go through that. I'll give you a chance to catch up. You can start going as far as example 1, and then we'll go from there. Here we go. So, in a way, composite functions is something you've been dealing with, since grade 9 or so, but it's never expressed as composite functions. And the first example I've got there is overkill for what we do. I might even, if it's okay with everybody, I might even zoom up on slide 3, unless just waggle a paw in the air if you're still on slide 2 there, the top corner. Cool. Just to make it a little bit easier for you to see what's going on there, because I've cramped it in a bit. So let's say g of x is equal to 2. Really simple. That's like a straight line, right? So that's a straight line graph. And then f of x equals x squared plus 5x, which is some kind of quadratic, right? Well, f composed with g of x would be, we take g of x and we work out what g of x is. Well, that's pretty easy. It's just 2. Okay, so we end up with f, change colour, of 2. Okay, can you see what I've done? I've literally replaced g of x with what g of x is, which is just the number 2. Remember, this rule here, g of x equals 2, simply means whatever I input into x, I just output 2, which is why it's a horizontal straight line. So if I input -7, the output is 2. If I input 0, the output is 2. If I input pi, the output is 2. If I input root 2, the output is 2. Every single input from x becomes 2 as the output. So the y value is 2. Okay? So the rule would be for the new composite function, f of 2, which is equal to, what I do now is I replace each instance of x with what g of x is, which is 2. So that would be 2 squared plus 5 times 2, which is equal to 24. I have to think about that. That's not right even. Try that again. I had to think about it and got it wrong. Sure. It just says 14 anyway. 2 squared is 4, plus 5 times 2 is 10, and that's equal to 14. Okay, are we okay with that? So in other words, when you evaluate a function for a given value, that's kind of like a composite function, because you replace the x with a number and then you evaluate to a number. Technically speaking, because what I've actually done is created a new function called f composed with g. F composed with g is a new function, which is basically whatever I input, I'm going to output 14. Okay, f composed with g of x is equal to 14. That's the new function. So if I input 3, out comes 14. If I input 10, out comes 14. If I input root 2, out comes 14, etc. That's the new rule. If I connect what I was doing over here, coming up with the new function, with what the final output is, which is 14. Okay, so f composed with g is just f g of x. Are we okay with that? Okay, I'll zoom out again because I've got a second example. In example 2, and I'm just going to move the Vivi thing again. I think I'll go to the top corner this time. It's exciting, isn't it? And what's more exciting is that this makes no sense if you're looking back at the video, because the video is only capturing the browser tab, which means me saying all this means absolutely nothing at all. But then again, some students would say that's pretty standard for Richard. Okay, example 2, g of x equals x plus h. Hooray. F of x equals x squared plus 5x. So I've kept f of x the same. I'll leave that zoomed out, but I'll just zoom in for myself. Okay, f composed with g of x, the new function f composed of g of x is worked out by considering f of g of x. Is that okay? It's not too small down the back? Or it is? Let me know. All good? Cool. Okay, this is what the new function is going to look like. It's going to be whatever turns out once I've applied g of x to f. Well, what is g of x? Not just a number this time, it's x plus h. And so f composed with g of x is equal to f of x plus h. Now, I started off this by saying we have already been using composite functions, and I've followed up with 2 examples. Where have you seen f of x plus h before? Sorry? Yeah, Lim. Yeah. So calculus, right? Do you remember the fundamental way we work out a derivative? F dash of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h, right? So when we go f of x plus h, we are using a composite function. We are saying replace the input x with a new rule, which is x plus h. And so this becomes, there was an x squared here, so now we have to say the input is x plus h, all squared. Plus 5, lots of, it was x, it's now x plus h. So I could then expand that if I wanted to and collect like terms. I'm not going to do that just for speed's sake, but that's the critical step there. X plus h all squared plus 5 outside of x plus h, that is f composed with g of x. And again, I should put the pause in the right spot for you. F composed with g of x. Okay, so f composed with g is the new function, of x is the input to the new function f composed with g. And the new rule would be x plus h all squared plus 5 outside of x plus h. We don't know what h is, it doesn't matter. That's like I was saying back here, it's kind of similar to this. We're going to put a c in, doesn't matter. We're just putting in something for x. Doesn't matter how complicated that something is. It can be another variable like h, or a more complicated expression like x plus h, etc. Okay, I need to switch pages if everyone okay with that. Okay. So, if you have 2 functions, f and g, f composed with g is not, it can be, but generally it's not the same as g composed with f. If they are the same, that's just a coincidence or the way it's structured effectively. I shouldn't say it's a coincidence. You can very deliberately make it so that it is true, but it's only under certain circumstances is f composed with g the same as g composed with f. Okay, I've got an example there. We've got f of x equals 3x and g of x equals x squared. I might just pause the video and give you a second to see whether you can get ahead with this, and that will kind of confirm whether you're kind of okay with this kind of stuff before we move on. Can you work out what f composed with g is? That should be reasonable to do. Maybe. It's okay if it's not. You only have to wait a minute and then I'll go through it anyway. And then what does it mean for g composed with f? So, first step, in my opinion, this is what you should do anyway. First step is to replace the inside of g of f of with g of x. So the next step for me would be to say, well, g of x is simply x squared. So it's f of x squared, like so. Okay? So again, just to clarify what we're doing, is we're doing like an interchange. We're doing a swap. Wherever there's an x in the f rule, we are now going to swap it with an x squared. It is a straight swap. Okay, so the next line is going to be take the 3 and swap it with the x squared. So that becomes 3x squared. Did I say take the 3 then? Damn it. Take the x in f and swap it for the x squared. It is a straight swap. So it's not 3x all squared. We're not squaring 3x. We are just replacing the x with the x squared. It is simple as that. Don't overthink it. So that's your fog done. That's your f composed with g. If I go g composed with f, then that would be g of f of x. Don't get too caught up with what those letters are. I could say h composed with k of x. As long as I know what h of x and k of x is, I'm good to go. So the letters are just follow your nose from there. What is f of x? F of x is equal to 3x. So the new input to the function g, the new input is 3x, which is going to be passed into g of x. G of x is x squared. So order of operation says I'm squaring x. I'm squaring x. My new input is 3x, so that's what I have to be squaring. So I have to replace x with 3x. It's a swap. It's a straight swap squared. The brackets need to be there because it's a compound term, right? It's not just a single letter. It's 3 times x. I'm squaring all of 3x. I'm not just squaring the x bit. So if I do that and now simplify, I'll get 3 squared is 9x squared. So f composed with g gives me 3x squared. G composed with f is 9x squared. So I'm going to give you some practice time now. And again, I just want to emphasize this, that it's a matter of practice and me helping you out. But ultimately, you need to effectively just be swapping in and out of expressions like I've been showing you here. Wherever there's an x, every single time, say this one here, wherever there's an x, I've simply replaced the x with whatever g of x is to get a new expression, and then I've simplified the expression. That's all you're doing over and over and over again. Okay, so I'm going to give you till 9:15 to practice this. Whilst you are practicing, I'm going to hand out your homework assignments. I'm going to pause the video. They don't need to hear this.